I'm just recapping. So yes. Okay. And so if you're given this point, this polar point, and if you want to write in different forms, represent different ways, the formula is R, given R and a theta. You can write this as R. It does not change, but you can add 2 pi to the angle or minus 2 pi to the angle. Okay, so that's one way. Or you can put the sign of R, right? Put the sign of R. So R comma theta. You can make R negative, just flip the sign. And when you do that, though, you got to add what to the angle. Not for this one, just pi. When you put the sign of R, you just add pi to the angle or minus pi. Good? All right. Okay, let's do this example. 9. Okay, so I can write this as negative 1.5. Okay, that's not going to change, but it's pi over 6. So what I'm going to do now is pi over 6. I'm going to add 2 pi plus 2 pi. Okay. But when I add 2 pi now, I'm going to write the 2 pi as a fraction. So I'm writing this as 6 and 12 pi. That is still 2 pi. Now I can combine them because they have the same denominator. So that's going to give me now negative 1.5, comma, pi and 12 pi is 13 pi over 6. Everybody see that? So all I need to do is I just go one revolution around. I just add 2 pi. Another way I can do is instead of going that way, I can go the other way around. And that means I'm just going to minus 2 pi. So again, negative 1.5 pi over 6. I'm going to minus 2 pi this time, which is just 12 pi over 6. Good. And when I do that now, that gives me negative 1.5, comma, negative 11 pi over 6. Good. So that's 2 ways so far I've done it. The next way now is I'm going to make R negative. I'm going to put the sign on R. Put the sign on R. Here R is negative 1.5. I'm going to make it 1.5. I'll flip the sign on it. But when I do that now, this time I'm going to add pi to the angle. Not 2 pi this time. And that gives me 6 pi over 6 for that pi. And so here I go now. That gives me 1.5, comma, pi plus 6 pi is just 7 pi over 6. Okay. So that's what we did yesterday. Good review on that one. All right. Yesterday we did not finish this. That's polar distance. Just like how you can find distance between 2 points on an XY plane, you can find distance between 2 polar points. And it's a formula. It's D is equal to, given 2 polar points, P1 and P2, the distance is going to equal to R1 squared plus R2 squared minus 2R1 R2 times the cosine of the difference of the angles, right? Theta 2 minus theta 1, the difference of the angles. And that's all under minus 2R, minus 2 times R1, R2. That's the formula for the distance between 2 polar points. All right, let's do an example. Let's do number 10. Where? Here. Distance is equal to, that what we're talking about? Oh, right here? Minus. If you decide really, I mean, if you were If you're going to be a kindergarten teacher, no, obviously not going to use that. But if you are your career is going to be in the STEMs, science, engineer, it may not be polar coordinates. Okay. This definitely gonna when you go to calculus 2, some of you guys, definitely calculus 2 and calculus 3, definitely this is heavy in calculus 2 and calculus 3, polar coordinates. All right, here we go. So let's fill the blanks now. This is really filling numbers. So I'm gonna get now the distance. This all under a square root. Okay. Let's look at these 2 points right here. This call this my P1. That's my P2. Good. My R1 is 2. So we're going to square that. That gives me 4 plus. My R2 is 3. Square that. That gives me 9. Minus 2 times R1, R2. That's going to give me 2 times 3. And now times the cosine of the difference of the angles. So that's going to give me now 7 pi over 4. 7 pi over 4 minus pi over 3. Say again. P1, P2. Lost me there for a second. Okay. All right. 4 plus 9. Let's simplify this now. 4 plus 9 is 13. Minus 2 times 2 is 4. 4 times 3 is 12. So minus 12. Times the cosine. Now let's simplify this now. 7 pi over 4 minus pi over 3. How do we combine those two fractions? Exactly. Make them have the same denominator. So that's my eraser. And if I could find a marker, just when I need one, two, one. Oh. Okay. So 7 pi over 4 minus pi over 3. Again, they must have the same denominator for me to subtract them. So I'm going to multiply this by 3, that by 3, and this by 4. Okay. 3 times 7 is 21 pi. 21 pi over 12 minus 4 pi over 12. And that gives me 20 minus 4 is 17. 17 pi over 12. Okay. So now I can write this as cosine of 17 pi over 12. Everybody see that? And that's under. Right. So the calculator, you punch out in the calculator and see what you get real quick. Say it again. 4.01. So the distance between both points is 4.01. Okay, 4.01. Good. Okay, really quick, try number 11 on. Try number 11 on your own. Number 11. Yes. 4.0. Is it calculating radians? Okay, what do you get? They take the square root. You get the square root of that. Take the square root of that. There you go, young scholar. The distance is 4.01 units. Yes, that's the answer. 4.01. Oh, I want to go to California this summer. Right now, the ticket is $272. This is a good time to buy the ticket now. Yeah.
So you're gonna
LA. I've not. I've been to California 3 times, but I've been there when I was in the Army. So I go to the desert all the time. I've never been there to visit, so I want to take the family there. All right, try number 11, guys, real quick, so we can move on to this. For number 11. Oh, that's what you're asking for. Number. Oh, I know. It's 4.01. Yeah. Oh no, no, yeah. Say again. Yeah, that's 4 point. That's the answer. You didn't get it?
No. 12 cosine.
17 power of 12.
17 power of 12 is negative 3.1. So it'd just be negative, it'd be 13 minus 3.1.
Okay, you have 12. Did it take the cosine of this? What does that give you? 3.1?
12 cosine of
17 power of
2
It's 17 power of 12. All right. Yep.
Oh, wait. 4.01. Oh, I meant.
Sorry. You should, and I'm not sure. I don't use. Yeah. What are you doing?
If it's in radiant, is it supposed to be in radiant?
Yes,
Okay.
it's in radians. 10 cosine. You have negative 7. It's 17 pi. You have, what is this right here?
17.
Oh, so you did number 11?
Yeah.
Oh, I'm sorry. What's? Oh, no. The answer for that one is if you've done number 11, the answer is 4.16 for number 11. Okay, real quick, let's fill this out. Okay, my R1 is gonna be -1, so that's 1 square. That's gonna be 1 when I square -1, plus my R2 is 5 squared, that's 25, minus 2 times -1 times 5 times the cosine of 2 pi over 3 minus 11 pi over 6. And that's all under square root sign. That gives me 26 plus 10 times the cosine. When you combine these two angles, that gives you 4 over 6 minus, that's 7, negative 7 pi over 6. Good? Yes. I was afraid you're going to ask that. It's been a while since I did that. Just check this one. What is this one? This one's in radians. I got to go back and figure that out. Yeah, it's been a while since I did that. I don't remember. Looking at that too? Oh, change it. Okay, got it. Okay, are we good on this, guys? It's just plugging up. It's just plugging numbers into the formula. Good. Oh, homework. It's gonna be in this too. It's gonna continue what we did. All right. Yeah. All right. Yes, sir.
The answer was 4.01.
I think it's 4.16 is the answer. 4.16. It's 26 plus 10, not minus 10. Because there's a minus sign right here. -2 and -1 gives you a positive. So, all right, guys. So that was yesterday's lesson to find distance between 2 points. Yeah. Today we're gonna learn how to graph polar equations. Okay. So let's go to polar equations. Boom, 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 boom. Yes. Hmm? Take the square root. All right. So let's look at view zoom. Let's look at polar equation. Now in the xy plane, right? When we have functions, okay, here in algebra algebra 2, right? You learn y is equal. You're given a function y is equal to f of x, right? We know that x is the input, right? You put x value to the function, and the y is your output. That's your dependent variable. Okay. In polar function now, it's written this way: r is equal to a function of theta, where in this case now the angle is your independent variable. That's your input, and r is your output. So an example would be this: r is equal to 2 cosine theta. That is a function in polar coordinates. You input the angle. Suppose the angle is pi over 6, right? All right, let's go pi over 3 then. Cosine of pi over 3 is 1/2. 2 times 1/2 is 1. So r is equal to 1. So the angle is your input, right? The r is your output. Everybody see that? What part you don't see? When you see everything, what do you mean everything? So f of theta. So this is just, okay, this you're familiar with, right? Y equals f of x, same thing, right? This is a function right here, and that's your output. So the way I can write this is an example: r equals 2 cosine theta. Here, it will be an example will be y is equal to 2x plus 1. Right? It's the same concept. This is linear, this is polar, right? X is your input, the angle is your input. Your output is what r equals to. Good? Okay, I'm getting there. I'm getting there. So let's look at number 1. R is equal to 2. What does that look like? Well, let's look at this example here in linear. Y equals 2. We all know what that looks like. It's a horizontal line. If I plot this, right, y equals 2, suppose I make my t table, x comma y. It doesn't matter what x values are, y is always 2, right? So I could have -2, y is going to be 2. If x is 5, y is 2, right? The x doesn't matter. Y is always 2. That's why the line is a straight line. It's a horizontal line. Same concept with r equals 2. Here we go. I'm going to make my t table. But in this case now, I'm going to have my angle as my, this is like my x, and r is your y, right? So here, it doesn't matter what the angle I have. It could be 0, pi over 6, pi over 3, pi over, let's make a 7 pi over 6. It does not matter what the angle is. R is still going to be 2, 2, 2, all right? So let's plot this now on the graph and see what it looks like. When the angle is 0, R is 2. Good? When the angle is pi over 6, what is R? It is still 2. Pi over 6 is 2 right here. When the angle is, let's make this pi over 2. When the angle is pi over 2, again, R is still 2. When the angle is 7 pi over 6, 2, right? So when I connect this dots now, what does it look like? A circle. So R equals a number is just a circle of that radius, R equals. So, all right? Huh? It's 2. It's like your XY. You can change those numbers. It doesn't have to be, you can change this number. Here it is 2. Here it worked fine. It is 2. All right, you can change them. All right. Now, if you notice now, when R equals 2, I started on the right side, right? When starting right side, right? And I start. What if R is negative? Let's make this -2. R equals -2. Let's see what it looks like then. So let's make this -2. Okay? And it doesn't matter what the angle is, my R is -2. The only difference though, when I start, I'm going to start on, let's see, when the angle is 0, -2 is, it's going to be on this side over here. Pi over 6, R is -2. Pi over 6 is right here, right? But I'm going to go to the opposite side for -2, right there. Pi over 2 is right here, but R is -2, so I'm going to come down here and find -2. So you notice it's still going to be a circle when R is negative. It's just I'm starting on the other side, all right? Starting here, and I'm going to go around. I still get a circle because you started on the other side when it's negative. Good. Say again. What numbers?
The numbers.
The angles are. The angles. You just like when you make a T, X, Y. You just pick numbers. Here I'm just using the angles on a circle. That's all I'm doing. Just to put random. All right. So that is no. What happens when the angle is pi over 3? All right. You remember in the XY plane, right? X is your independent variable, and that when X equals 4, what do you have? A vertical line, right? Same concept, right? So it doesn't matter what the Y value is going to be, it is still 4. So here we go. Okay. All right. The angle is pi over 3. Okay. It doesn't matter what the R value is, my angle is still going to be pi over 3. So I can pick -2, -1, 0. What's the maximum number? I can pick 6. All right, I'm picking 6. It doesn't matter because the input value is still the same. They're all going to be pi over 3. The angle is pi over 3, pi over 3, pi over 3, pi over 3, pi. Okay, so let's plot this now and see. The angle is pi over 3. So let's find pi over 3 on the circle. Again, I'm doing number 3. I'm just working off this one here. Okay. All right. Pi over 3, -2. I didn't do 0, but I'll skip 0. Pi over 3. All right, that's pi over 3, but it's -2. Right, this is 2 right here, but I gotta go to the other side for -2. So that's -2 right there. Good. Okay. -1 for pi over 3. Again, -1. I go on the other side. That's -1 there. Oh, I did 0. Okay. Pi over 3. When R is 0, is just at the center. Pi over 3 when R is 6. Well, 6 is right here. You see what's happening right here? What is it going to be? Pi over 3, R is 4. Where's R is 4? Oh, no, that's 4 right there. So what am I going to have when I click all those dots? A straight line. Okay. So when you're given theta, when is equal to a number, an angle, all you have is a straight line on the angle. Okay. It's an angle. It's a straight line through the angle. Yeah. Okay. Are we good so far on that one? So when R is a number, we have a circle. When theta is equal to an angle, it is a straight line on to the angle. All right. Let's look at number 5. R equals 2 sine theta. What does that look like? Okay, I gave you you have a blank sheet of paper, you can follow along with this. What we're going to do again, we're just going to graph this with all the angles we can use. All right. And so what I'm going to do is this now. I'm going to do a few of the angles. I don't have you do the rest. Okay. So when the angle is this, like your X and Y, guys, your X and Y. All right. This is my input. I want to find my output. Okay. So when the angle is 0, what is R equal to? Well, sine of 0 is what is sine of 0? Look at your chart. What is sine of 0? 0. Sine of 0 is 0. And then 2 times 0 is, that gives me a 0. Everybody see what I did a while ago? Let me pause for a second. Everybody with me? Okay, I see some of you guys working. All right, good. Pi over 6. Sine of pi over 6 is times 2. 1. Go ahead and fill out the rest, and I'll give you a couple minutes to do that. You're already done. The sine of pi over 6, the angle is pi over 6 now, so I'm going to have the sine of pi over 6 from the unit circle, that is 1/2. I have a 2 right here, so 2 times 1/2 is 1. If you're done, just go ahead and plot those points on the graph. Okay. Ashton is not here. Vanessa is not here. Irene. Vanessa. All right. So pi over 3. All right. This side of pi over 3. And for you guys going to BC and these numbers, you'll get to know them by heart. Square root of 3 over 2 is 0.866. Square root of 3 is roughly 1.7. All right. You'll know those eventually. So the sine of pi over 3 is square root of 3 over 2, which is 0.866 times 2 gives you 1.7. Okay. Sine of pi over 2 is 1 times 1 is 2. Sine 2 pi over 3 again is square root of 3 over 2, which is 0.866 times 2 gives you 1.7. And sine of pi over 6, that is 1/2 times 2 gives you 1. Okay. Sine of pi is 0. 7 pi over 6 now. I'm now in the third quadrant now. So sine is going to be negative here. So sine of 7 pi over 6 is going to be negative 1/2 times 2 is negative 1. Sine of 4 pi over 3 is point. Huh? Well, yeah, exactly. Negative 1.7. This is going to be negative 2. This is going to be negative 1.7 and negative 1. Okay. Everybody good so far? All right, just plot this points on the graph now. Now this is going to give you a shape. Hopefully you recognize it. Okay, when the angle is 0, R is 0, so that puts me right there. Different color. Okay. When the angle is pi over 6, that gives me 1. Pi over 6, 1 is right here, so that's right there. Pi over 3, it is 1.7. So this is 2 right here. This is 2. This is 1.5. So 1.7 is somewhere close to 2. I want to say right around there. Okay, it's 2. 1.7. When it's pi over 2, R is 2. So that's pi over 2, R is 2 right there. And then next one is 2 pi over 3. That is 1.7. 2 pi over 3 is right here. 1.7 is going to be right there. And then 5 pi over 6, we have 1. And 1 is 5 pi over 6, which 1 is right here. Okay. And then again, when the angle is pi, we're back at 0. 7 pi over 6 is negative 1. 7 pi over 6 is negative 1. That's 7 pi over 6 here, but negative 1, I got to go on the other side. So if you notice now, I'm starting to hit the same points over again. 4 pi over 3 is negative 1.7. That's 4 pi over 3, but negative 1.7, I have to go on the other side, which is right here. So you're going to hit the same points, okay? All right, so let's try to connect dots and see what we get. Okay.
Oh, it's like this.
That's not what?
Wait, it's like this, but it's moved.
Yeah, exactly. It's a circle. All right, it's a circle. And tomorrow when we learn how to convert, you'll see that it's a circle shifted on the y-axis, right? So this is a circle, not the best circle. And this is one of the formulas you will learn, you'll come to learn or memorize. Okay. Let's go over here. Okay, put this in your notes. Okay. Now, if you look at it now, on the unit circle, we know that sine is associated with a y value, cosine with an x value. This is a circle on it's a circle sine function, so it's on the y-axis, and the formula for a curve that is like this is r is equal to a sine theta. Whenever you see r equals a sine theta, it is a circle. The diameter of this circle, if you look at it, this is 2 right here on the circle. I'm trying to find the right word. So the diameter is 2, right? Which is the same as the coefficient right there. So this is a circle. A is positive. That's why it's above the polar axis. If A is negative now, it will be, if it was a -2, then its circle will be down here. All right. So when A is positive, right? When A is positive, we have the circle above, all right? And when A is less than 0, when A is negative now, the circle is below. And A is your diameter. Good? R equals A sine theta. You will come to know that that's a circle in polar coordinates. All right. Now, if this was R equals A cosine theta, where do you think the circle would be? And the left and right. Okay. If A is positive now, then we look like this. Okay. And that's when A is greater than 0. And when A is less than 0, then it will be on the other side. Good. So just remember those. Okay. Sometimes you'll see it written as R is equal to plus and minus a sine theta, or r is equal to plus and minus a cosine theta. Good? What's up? It's on the right, and when it's less than 0, it's on the left. Okay. All right. So let's look at number 3. Where is this going to be on the graph? If I graph it on the where? It will be down here, right? Because it's a sine function, should be down here. R3 will be the radius. So this circle will be, this is 1, 2, 3. It'll be all down there, right? With R is 3. Good. All right. One more before we go. I want to show you this one here. Let's look at boom, 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 boom. Okay. R equals cosecant theta. What does it look like? Okay, so let's go ahead and draw your let's find some values for these. You can when you solve this, use 1 over sine theta. Okay, R is equal to 1 over sine theta. So I'm gonna draw my T table here. Okay. That's my angle, and that's my R. And I'm gonna just pick angles around the circle. Okay. So we're gonna start out with 0, pi over 6, pi over 3, pi over 2, pi, and then we have I can't stop that. No, pi was, sorry, I missed two of them. 2 pi over 3. I need to change color. 2 pi over 3, 5 pi over 6, and pi. Okay. We probably not end up using all of them. So let's go ahead and find R value now. So we're going to use R is cosecant, but we can, to make it easier for us, we're going to say 1 over sine theta. When the angle is 0, sine of 0 is 0. So what is 1 over 0? If you say 1 right now, I'm going to pull my hair out. No. 1 over 0 is undefined. Okay. Okay. All right. Pi over 6. Sine of pi over 6 is 1/2, but it's 1 over. So we flip it, it becomes 2. Okay. Sine of pi over 3 is square root of 2, and I have that 1. That is, when we do that, that's 1.2, roughly 1.2. Right? You can do this one. This is sine of pi over 3 is square root of 3 over 2. But when you flip it, it becomes 2 over radical 3, which is roughly 1.2. Okay. Sine of pi over 2 is 1. That still becomes 1. Okay. And sine of 2 pi over 3, again, is the same as 1.2. I'm going to stop here because you'll see the shape that's going to take. Okay, so let's plot these right now. Okay, when 0 is undefined, pi over 6, it is 2. Okay, pi over 6, we're going to get 2, which is right there. All right, pi over 6, that's 2. Pi over 3, we have 1.2. So if this is 1, this is 1.5. So 1.2 is going to be somewhere right around there. Pi over 2 is 1. So that's pi over 2, 1 is right there. 2 pi over 3 is 1.2, which is, you can see what kind of shape this is, all right? That is a butterfly. It's a straight line. Okay. So now let me ask a question now. If y equals cosecant theta is a straight line, what is y equals secant theta? What do you think that's going to be? Vertical line. All right. Tomorrow we're going to pick up. Tomorrow we're going to discuss some more shapes. kind of a little bit behind in class, like one topic behind this class, but we'll be fine. Okay, homework. Let me see back for a second.
Sorry, you scared.
We're gonna finish up. Listen, guys, homework. We're gonna finish up what we started yesterday. This is homework 1. You did 1 through 10 odd numbers. Today, do 11 through 19 odd numbers. 11 through 19 odd numbers. Huh?
You just said
13?
Is it 19? Oh, yeah, the word problem.
Oh, you can do that. It's pretty easy.
Oh, yeah, it is.
Yeah, it's the same thing points. Yeah. All right, guys. Good job. Good job.
It's secret. Gonna have favorite ones.
No, you should. What?
Oh, wait.
Uh,
not gonna be here.
I'll put it on canvas.
I don't know.
Converting between polar and rectangular, so we go back and forth. I don't know what you did here.
I don't think it's supposed to be this one. I thought it was supposed to be this time, but I don't know why.
Yeah, I know what you did. You did a lot of work on that. Is that your homework? Okay, wow. All right. No, I just saw a lot of lines. I wonder what you done. All right. It's wrong, right? Should I say it's wrong?
Is it?
Should I say what? What? Oh, number one.
Is it not?
Oh, are you asking me? Okay. No, it should be it's a vertical line and it's gonna cross on 4. Where's 4 on it? Should be over.
4 is right here.
Yeah, that should be a vertical line to 4.
Okay.
Good.
But I don't know what. So if it's on this side, that would be
Negative.
Okay, that makes.
Good.
Yeah.
Woo! Woo, 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 woo.